In this video, we will build on the previous two videos on the chain rule. We will start by looking at applying the algebra skills of factoring to a more complicated expression. Then, we will look at differentiating functions that require the application of the product rule or the quotient rule along with the chain rule. To begin, we will look at factoring an expression that is more complicated than you would have seen in a traditional algebra class, but we'll use the same techniques that you developed there. In an expression like this, if we want to factor, we first look for the GCF. Let's look for the common expression or expressions. And we always look at factoring out the common expression using the lowest exponent on that expression. In this case, the common expression consists of a factor of 3 and a factor of x plus 2. So whenever we go to factor out, we will see that we'll have 3 times x plus 2 will be brought out. Now the factor of x plus 2 will have an exponent that corresponds to the lowest exponent on x plus 2. So between the two exponents we have 2/5 and negative 3/5. So in this case, negative 3/5 is lower, so the exponent will be negative 3/5. Since that's the GCF, we'll factor it out, and we'll go ahead and look at what we're left with. To determine that, we'll look at distributing this quantity throughout in order to obtain the original expression. So if we look at 3 times the quantity x plus 2 to the negative 3/5, what would it take in order to obtain our original first term? So we already see that we need a 7th of, and then we did not factor out x plus 2 to the 2/5, so we're going to have to multiply by something in order to obtain that 2/5 power. So whenever I multiply x plus 2 to the negative 3/5 times x plus 2 to the unknown power, what would it take in order to obtain 2/5? Now whenever we multiply, we add those two exponents. So negative 3/5 plus what is 2/5? And the answer would be 5/5, because negative 3/5 plus 5/5 is 2/5, but 5/5 is nothing more than 1. Now we'll look at our next term. 3 times x plus 2 to the negative 3/5. We'll need what in order to become the second term? Negative 3/4 x plus 2 to the negative 3/5. So I've already factored out the 3. I'll need a 4th. So minus 1/4. And I've already factored out the x plus 2 to the negative 3/5. So that's all it would take. So this would become 3 times x plus 2 to the negative 3/5 times 1/7 x plus 2/7 minus 1/4. And now we can clean this up using algebra. 3 times x plus 2 to the negative 3/5 times 1/7 x plus 1/28. Now x plus 2 has a negative exponent, so I can move that to the denominator. But now you'll see that you have fractions within a fraction. So we need to clear by multiplying the numerator and the denominator by the appropriate LCD. So we will be looking at the 7 and the 28 for that LCD. So the LCD would be 28. So if I multiply the numerator by that in order to clear the fraction, then I multiply the denominator. And so we obtain, now I only need to multiply the 28 by one of these. It's either going to be the 3 or this expression. So I'll choose to multiply the 28 by this expression. I'm not distributing the 28 to the 3 and to that quantity. So we have 3 times 4x plus 1 over x plus 2 to the 3/5. Now we will take a look at an example where we have to differentiate a function using the product rule, and then in the midst of using the product rule, we'll have to use the chain rule. So here we have a function g of t, which is a product of two functions. So we will use the product rule. So g prime of t will equal the derivative of the first times the second plus the first times the derivative of the second. So this is just an application of the product rule. This is now equal to the following expression where we have to use the generalized power rule on this function. So I will bring the 5 in front, lower that power by 5, and then because there's an inside function, I need to take the derivative of that inside function. So again, I'll bring the 5 in front. For a moment, I'll ignore the inside function, lower the power, and then we'll take the derivative of the inside function. The inside function is 3t minus 5 times, now we just carry down the second function in the product, plus, and now we carry down the first function in the product, and again we need to multiply by the derivative of the second function, which requires, again, the generalized power rule. So I'll ignore the inside function, bring down the 8 in front, lower the power on 8, and now because there is an inside function, I will take its derivative. So again, bring down the power in front, ignoring the inside function for a moment, lower the power, and now take the derivative of the inside function that I originally ignored. So we obtain 5 times 3t minus 5 raised to the 4th times, now the derivative of 3t minus 5 is just 3. Carrying down the appropriate quantities, we obtain all of this, and the derivative of 2t plus 9 is just 2. So now let's tidy this up. The first quantity this particular item will be 15 times 3t minus 5 raised to the 4th power times 2t plus 9 raised to the 8th power plus, now we'll look at the second quantity. So we have 16 times 3t minus 5 to the 5th, 2t plus 9 to the 7th. Now we will look at finding the GCF of these two quantities. So if I look first at the numbers in front, the coefficients that is, 15 and 16 don't share a GCF. So we can look at 3t minus 5, which is common to both, and factor it out. 3t minus 5, and we will use the lowest power on that, which is 4. Then we also see a 2t plus 9 common to both, and the lowest exponent we see is 7. Now we can look at what is left over. So from the first quantity, we have a 15, but we factored out all the 3t minus 5s, and we factored out all but one of the 2t plus 9s. So we're left with 15 and 2t plus 9, which, if we were to distribute this quantity to that first term, we would obtain this term. Now let's look at the second term. Plus, now we did not factor out a 16, so that will remain. We factored out all but one of the 3t minus 5s, and we factored out all of the 2t plus 9s. So we will be left with 16 times 3t minus 5. And again, if I distribute this to the second term, it corresponds to what we would have in our second term of this expression above. And now we can simplify. We have 3t minus 5 raised to the 4th, 2t plus 9 raised to the 7th, times 30t plus 135 plus 48t minus 80, which finally results in 3t minus 5 and quantity raised to the 4th, the quantity of 2t plus 9 raised to the 7th, and collecting like terms in this leftover polynomial, we obtain 78t plus 55. In this example, we'll look at finding the derivative of this function, which is 5x squared times the square root of the quantity 16 minus x squared. Now, to assist us in taking the derivative of this function, let's first rewrite y. So y would equal 5x squared, and we are rewriting y so that we can see the generalized power rule, because the square root is simply a power of that expression. So we have 5x squared times this half power of the quantity 16 minus x squared. So to differentiate, we need the product rule. So again, we will take the derivative of the first quantity, so d dx of 5x squared, times now the second quantity, 16 minus x squared to the 1/2 power, plus the first times the derivative of the second. So we obtain 10x times 16 minus x squared to the 1/2 plus 5x squared times. Now to apply the generalized power rule, I ignore the inside function of 16 minus x squared, and I just bring that exponent of half down, lower that exponent, and then take the derivative of the inside. So we have 1/2 gets brought out front. 16 minus x squared, lower the exponent of 1/2 by 1, which yields negative 1/2, times the derivative of the inside. So we have 10x times 16 minus x squared to the 1/2 power plus 5x squared times 1/2 times 16 minus x squared to the negative 1/2 power times, and the derivative that we find here of 16 minus x squared, it will be negative 2x. So the calculus is over, and now it's just a matter of applying our algebra skills. So let's clean up each one of these first. That first quantity won't change. However, as we look at this larger second quantity, we can start canceling the 2 with the 1/2. That negative will make this a subtraction. So just some tidying up. So minus 5x, and now we have an x squared times an x, which will be 5x cubed, 16 minus x squared to the negative 1/2. In determining what we can factor out of both of these terms, we can look first at our coefficients of 10 and negative 5, and we can factor out a 5. We have an x and an x cubed, so we can factor out an x. We have a 16 minus x squared in both, so we can factor out a 16 minus x squared, and we will use the lower exponent of negative 1/2. In determining what we're left with, we know that 5 times 2 is our 10. I've already factored out the x. Whenever it comes to the 16 minus x squared, and I want to know what power that should be raised to, I take the 16 minus x squared to the negative 1/2 and multiply it by 16 minus x squared to what power and obtain a positive half. Well, remember, we add those exponents. Negative 1/2 plus what is 1/2. And we find that the power that we will use is a 1. Minus, now we factor out the 5, we'll be left with an x squared, and we factor out all of the 16 minus x squared to the negative 1/2. And so we have 5x, 16 minus x squared to the negative 1/2 times 32 minus 2x squared minus x squared. And again, tidying up because we see a negative exponent and then we also see some like terms. This will equal 5x times 32 minus 3x squared all over the square root of 16 minus x squared. Or you could have left that as 16 minus x squared all to the positive 1/2 power. So now we'll take a look at an example that involves taking the derivative of a function that is formed by the quotient of two functions. In other words, we're going to look at using the quotient rule. And embedded in this process will be the application of the chain rule. So let's begin. We have f prime of x equals, now remember it's low d high minus high d low over the square of what's below. So we will start off with the denominator, x cubed plus 2 raised to the 2/3 times the derivative of the numerator minus the numerator times the derivative of the denominator. And this will all be over the square of the denominator. Now it's important to make sure that you write this denominator and carry it through. So we have x cubed plus 2 raised to the 2/3 times, and now we apply the chain rule. We can bring the 2 in front, ignore the inside function, lower the power, and then we take the derivative of the inside function. So 2 times 5x plus 1 raised to now the first power. Taking the derivative of the inside function yields for us this time 5 minus 5x plus 1 quantity squared times, and again we can bring the 2/3 in front and lower the power on the 2/3 and then take the derivative of the inside. So this yields for us 2/3 by bringing that exponent in front, x cubed plus 2, lower the exponent of the 2/3 by 1, which now makes it a negative 1/3, times, and the derivative of the inside function would be the derivative of x cubed plus 2. The derivative of x cubed plus 2 is simply 3x squared. So this denominator is now x cubed plus 2, and we multiply the exponents of 2/3 and 2 and obtain 4/3. Now let's clean up the numerator. We obtain 10 times x cubed plus 2 to the 2/3 power times 5x plus 1 minus 2x squared times 5x plus 1 quantity squared times x cubed plus 2 to the negative 1/3 power, and that is all over x cubed plus 2. Now don't get lazy and stop writing that denominator. Carry that denominator throughout. Equals now, and we look for that common factor in the numerator. So we see a 10 and we see a 2. So we can factor out a 2. We also see a factor of x cubed plus 2 in both, and then we can factor out that raised to the lower power of negative 1/3. Likewise, we see 5x plus 1 in both, and the lower power on it is simply 1. Leaving behind now, from the first term, we factored out 2 from the 10, which leaves behind 5. From x cubed plus 2 being factored out to the negative 1/3 power, we are supposed to obtain a 2/3 power if we were to distribute. So we have x cubed plus 2, and that will be raised to what power? Well, negative 1/3 will have to be multiplied by what power in order to obtain 2/3. Now remember that we will add these exponents when we multiply. So negative 1/3 plus what is positive 2/3? And that would be 3/3, right? Negative 1/3 plus 3/3 would be 2/3. But of course, 3/3 is just 1. Minus, now we factored out the 2, so we'll be left with an x squared. From the 5x plus 1 quantity squared, we factored out one of those, so we will be left with 1. And we factored out the x cubed plus 2 to the negative third power. Now we can take the x cubed plus 2 to the negative third, and we can bring that down to the denominator. We can also clean up this bracketed portion by distributing and collecting like terms. In so doing, we first obtain 2 times 5x plus 1 times, now we'll look at the bracketed portion of 5x cubed plus 10 minus 5x cubed minus x squared. Now remember, we took that x cubed plus 2, which was raised to the negative third power, and we brought it down to the denominator. So we'll have x cubed plus 2, and that power will now be 5/3, which yields for us 2 times the quantity 5x plus 1, and in collecting like terms, we see that we have 10 minus x squared, and that will be over x cubed plus 2, which will be raised to the 5/3 power. And that is our final answer.